Hey, y'all, it's Dr. Know-It-All. I'm with my frequent guest. You are definitely squatting on the virtual couch here. You're going to need a vacation from your vacation. I mean, I don't even know how many appearances you've made on YouTube recently, but Dr. Scott Walter, of course, we are very thrilled to have you. The proximate cause for this is that I will go ahead and present. First of all, welcome. And also, how was Verta? That was what you went and saw, right? Or heard at the opera?
Yes,
Okay.
yes. It was. Let's just say there was a reason we were able to get seats on such short notice.
Okay. Which opera company was it? Or do you
Oh,
not
it
want to
was
say?
the Zurich Opera. I mean, it was they did a
Okay.
nice production, but it's not necessarily my taste as far as a particular opera.
Yeah. Yeah, I
The
can
the last one
understand.
they did was quite interesting. So it's a wonderful opera house and a wonderful opera company.
Cool. All right. Anyway.
And unfortunately, it was a German author, Goethe,
Right.
but it was a French composer, so it was in French
Oh, so
with subtitles that were like a little bit too blurry for me to be able to read with my tired eyes.
geez.
So
Oh,
it
man.
was kind of hard
I'm
to
trying to
follow.
remember. I'm actually familiar. So it's a 19th century composer, right? It was not a modern opera. Yeah.
Yes.
Who did it? Was it Massenet or somebody? I
It
can't
was
remember.
matinee, something like that.
Yeah,
Yeah,
yeah. So
yeah.
anyway, so yeah, okay. So in another life, I actually do know opera reasonably well. So there you go. Weird stuff. But that's not what we're here to talk about today. We're here to talk about this. And that is, first of all, a big thanks to Sawyer Merritt for finding this. And I don't know where Sawyer gets all this stuff. He's just always finding things. But it's a 4K image of Optimus here. And then a really big thanks to Ed Howard. At Howard Models, I believe, is his link. Yep, Howard Models. So anyway, follow both of these guys if you're not. But he enhanced this. I'm going to stop sharing for a minute because I'm going to bring it up as its own independent entity so we can look at it very, very closely. So let me go ahead and stop that sharing. Unfortunately, you can't do two screens at once, which seems kind of strange on that's the first thing I've run into on StreamYard that hasn't worked quite as well as I thought. So here is the original, but I think we actually want to look at Ed's, right?
It adds, yeah. It gives much better contrast.
Right.
Because you have like a kind of black on black, which is really hard to see, and he did a
Exactly.
great job of enhancing. As I tried it, and all my attempts were kind of lame at first.
Yeah.
And this
Yeah.
one here, you really can see the edges of the bot a little bit better.
I,
Things kind
I'm,
of
I'm
pop out.
I'm thinking about that classic '90s thing: zoom and enhance, zoom and enhance. So
Hmm
we've got the enhance, so let's try the zoom. So we're gonna bring. I don't know. You want to start at the top and work your way down,
Yeah,
or
as I
what?
said, you want to go from head to toe?
Yeah, here we go. So here's the head, and I'll make it nice and big. That's about as big as I can go without overtaxing the screen. Uh, as with, interestingly enough, we've actually seen more about figures face than we have about Tesla bots, because we've seen kind of like it do that little funky, like, I don't know, startup look or whatever that is that
Right,
figure.
right,
But
right. And it doesn't appear there's any sort of output display on here that we're aware of.
right,
The two changes in the Gen 2, of course, the original one, the head did not move.
yes,
And in the
yeah,
Gen 2, the head's able to move. It's able to nod its head up and down. It's able to turn left and right. So it has 2 degrees of freedom. So
right.
they added 2 more actuators there. And by my calculation, they probably added about an extra kilogram by adding those in there.
Mm,
So for the
mm,
10 kilograms they lost, they added one in
right,
there. So it means they really got rid of 11 kilograms in a way somewhere else. But as far
right,
as we know, there is no information displayed on the face. Doesn't mean it won't eventually, but you do have that nice crisp outline that goes around there. Now,
yeah,
James Dalma has an interesting theory about that, because the question all along was, does the head really need to move? It doesn't seem like it needs to move. He
right.
thinks the only reason they put it in there is more or less for social integration, is that it
Okay,
makes it a lot easier
which is
to
fine.
communicate to the humans on where it's looking, because we're just kind
Right,
of used to that as a species, that we can read people's eyes and their head movement very well. Another thing, of course, the head has a nice profile. It has a nose and a chin and everything else you can see. So if someone is turning away from you, you can kind of tell very easily, whereas it
right,
wouldn't be so obvious without some sort of outline on there. And so that's why he thinks they have kind of that profile on there, is that you can see that and you'll quickly be able to tell whether Optimus is turning to the left or the right, or anything
right.
else. Plus, it seems like they can do different color of that strip
Yeah,
along there to be able to kind of tell you operational modes,
right.
whether it's functioning okay, whether there's an error or a fault, or whether some sort of danger signal. So that's James' theory, and it may be right, because it's cheaper to just put cameras all around rather than to move the head to look at something.
Yes. Yes. Yeah, it is. And definitely we've seen that that's definitely an LED strip around the outside. So
Yes.
it'll be able to have multiple colors. I would honestly be surprised if it doesn't have some sort of display on the face eventually, because
Hmm.
I think again, in terms of social integration, even if it's just like a cartoon smiley face or something, it's going to make people go like, "Oh, it's cute," you know. This is a
Yeah.
little more mysterious. So
It's possible. I've seen, well, there. I mean, if you look at the Baxter robot and some others, they tried doing that with kind of an iPad display of
yeah.
putting a
Yeah.
face on there, and it just seemed kind of gimmicky, and no one really liked it.
Right.
And
Right.
so, do you need to put eyes and other kinds of expressions in there?
You don't? I don't
Uh,
know.
it's possible. I mean, part of the display there is to maybe show status messages. But
Yeah.
if you have a language model and if you're able to speak with it, I don't really see the need for facial display to tell you what's going on.
Right.
Optimus can just tell you. And if you need diagnostic information, well, there's going to be some way that you're just going to have a laptop or something like that that you plug in to get the diagnostics.
Yeah.
So I'm not sure that they necessarily would go there because that might be an additional unnecessary cost, but we'll have to see.
Yeah. The only reason I'm wondering, and honestly, Tesla might have changed their mind over time, is that this is kind of that type of plastic slash glass that you would expect to see a display through.
Hmm.
Uh, It's like if it was more along the line of this kind of a harder surface or something where it was obviously not see through. But Tesla may have originally started off with the idea that they were going to need a display because, of course, even a couple of years ago, these large language models were not a thing. They didn't exist in any kind of substantial way. And so they may have
Right.
gone like, oh, we don't need that anymore. So in that case, maybe it will change eventually and go from that sort of shiny plastic to something a little more matte finish or something if they don't do that.
Right.
But
Now
but anyway,
we know from Walter Isaacson's book that they were sort of thinking about that, or a couple engineers were getting really focused on that, and Elon just
right.
said, "That's not important."
Yeah.
So he
Yeah.
like shelved that
Yeah.
all. So it may be that there's something that that's still in the back burner that eventually they would do, but right
Right.
now they do not seem to have a whole lot of importance to that idea.
Yeah. Or it ultimately could be a very, very low resolution, just a display to display error messages in case so it can kind of read out some text or something like that. So it would only pop up if there was a problem with it, just so that you could sort of like analyze
Yeah,
what was
yeah,
happening. So
possibly. But
yeah,
again, we're just speculating without knowing too much. But it's pretty clear that LED strip along there would be
right.
able to give some sort of status information that it would be typical on the shop floor. Red, green, yellow, orange, things like that.
Exactly, exactly. And of course we've got the addition of this. We'll see cloth in many places, but we've got cloth on this
Yes,
area so that it's flexible enough to move and still be a cobot so that it doesn't like pinch or something like
exactly.
that.
So now that the head is moving, you need some sort of flexible material around there to be able to
Right.
cover up all the potential pinch points and everything else that's there. Unfortunately, it doesn't tell us enough information about how that mechanism works. I
Yeah.
suspect it's just two stacked actuators together. James had some theories that it could be like a ball and socket where you could have these linear actuators to kind of move it around, like when you think
Oh,
of
interesting.
C3PO's head. But I
Interesting.
think that might be like almost over engineering. It might be easier to stack them together because, again, my theory has been that the role of the wrist, when you look at that motor that's there, it only shows up in one place on the bot, and all the
Right,
others have multiple purposes.
right,
So, and that's because it's such a low torque one. It seemed to me
right,
it was originally designed to also be able to do the neck, because the original design had the neck in there, and then
right.
they got rid of it. So I'm saying, going off the original design, I think they decided to put it back in there. They're probably using the original design of two actuators, one to be able to do this and the one to be able to do the neck.
Yeah, and potentially even they could be because if the head doesn't really have an awful lot of stuff aside from sensors in it, it wouldn't be that much weight, so it might be
Oh
able to
yeah,
get away with just
it,
the
it could be really
actuator.
small,
Yeah,
and it could be they came up with even like another actuator for that is really low torque,
right,
because it might be the one that's on the wrist. Well, it's a low torque one. Still has to do a little bit if you're carrying a
right,
load versus what's there. So yeah,
right.
we'll see. But again, if
Yeah,
they're using that one, that's why I'm guessed, because those were about half a kilogram, the size of those actuators. And
right.
assuming they've stripped it down a little bit, maybe it's a little bit less than half a kilogram. But by the time you put it on there, you've added about a kilogram. But at the same time, they had some structure there before to hold the neck together that's now been
Yeah,
replaced with something
yeah,
else. So I'm not sure what the trade off is.
right.
I'm guessing about a kilogram was added.
Okay. So let's scroll down a little bit to the shoulder area.
The
Unfortunately,
shoulder.
the more clean it gets, the less we can see. This looks a little stormtrooper-esque, by the way, with the way the light is shining off the chest plate and everything.
Yeah. Exactly, exactly. Now we can't tell much about the shoulders except that they're covered up really well now.
Yeah,
Before we could tell everything about what's going on the shoulders. So now it's
right.
very clean. I suspect everything is sort of similar underneath it. That you have 3 serial actuators, all the same size, that go in there to give you kind of the roll pitch yaw kind of shoulder. So probably nothing mysterious there. And actually, we might. Well, what do you think the material looks like there on those covers?
So yeah, so we've got clearly there's a difference in material between this sort of strip that's going around the shoulder pit and shoulder area and the head. But it's I think what you said earlier in your tweet, it looks like pleats are back
Hmm.
in style. It looks like we've got some sort of potentially rubber backed material that has some degree of
Right, right.
flexibility to it.
Yeah,
Um,
exactly, exactly. And so if you go down to the elbow, you see that for sure. So if we
yeah,
zoom in on the elbow area where
right,
those covers are, we're
right.
able to see that that's very pleated. That's
Yeah,
it looks like an accordion. Now the big mystery to me has always been why that is such a large area there around the inside part of the elbow,
exactly.
because I don't
Well,
see
let's
a mechanism going through there.
before we move to I do want to move to the elbow quickly,
Yeah.
but just quickly to just like finish out the shoulder area. So obviously you would have one sort of rotational actuator here so that the arm can rotate up and down this way. Then we have
Yes.
this motion here, which you can clearly see is also covered by um, some sort of cloth
Hmm.
material or pleating or something. And then the actual sorry, it's hard to do this. This kind of motion is actually in this third area here. It looks like that is
In the third, and you can kind of see a ring around there. So when you
yeah,
zoom in on the shoulder, you can see
right.
that ring that goes around there. And when you look at it very closely, you can see that the tolerances there are very tight.
Yeah, and I
So
like that
there's no
you noted
noticeable
that
gap there.
too. When we look, if we just skip down to like the legs for a second, I mean, these
Yeah,
tolerances are pretty tight here amongst all of these different
yeah, those
pinches,
move.
fingers. These are
Hmm.
very nice. So yeah. Anyway,
And you go
don't
in the
want to get
lower
ahead
part of the wrist, you begin to see a lot more there as well. So
right,
you have a kind of a roll axis on the lower arm as well as in the upper arm, and
right.
you can see where the two parts come together, and you'll see there's
Oops,
very little
sorry
gap in
about
there.
that.
So I kind of joke that yeah, there's no panel gaps. No one will be able
No,
to complain about that. So
he seems
it
to
seems to
prefer
be
the panel gun.
really well engineered, really well finished when you kind of look at how
Right,
well everything kind of
right.
fits together in many many different places. Now the
Yeah,
one thing is I want to kind of rely on your aesthetic eye that when you zoom
sure.
back and look at the whole bot holistically, um, do do all the colors and everything match? Does it look do all the white elements seem to be made out of the same material, or do you get the impression they might be slightly different materials? Is the color off a little bit on where you think the structural members are
The
versus the covers?
place that I would imagine, because clearly I think most of the rest of this is all cover, but the one place
Hmm.
I noticed that this has to be structural is the calf area
The
because
calf
that
and the lower arm. If you look at the wrist area as
oh yeah,
well.
yeah, this area
Yeah,
too.
so
Yeah,
those two are there, and when I looked at it really close, it's like the color match is pretty darn good, but I get the
yeah,
feeling that they're slightly different materials, and I
right.
don't know if it's just the lighting, the fact they're angled a little bit different, but my
Yeah.
gut tells me it's not the same material, but
Yes.
they've done an exemplary job trying to get them to match. Now,
Yeah.
um, I talked to my daughter, who is like the additive manufacturing expert in the family.
Right.
She
Good to
knows
have one of those around.
yes, yes, and the first impression is, do the covers look like they are 3D printed, or do could they be injection molded or something like that?
Right,
And the overall impression was that you can't really see any indications that it's 3D printed, because usually there's some sort of pattern or something you would notice.
right,
But again, this is only a 4K image; it's not really high. But
right.
she says that
Well,
with a
and
certain
you can
amount of
also
post
go back and
processing,
polish
you wouldn't know.
these
Yes,
things. Yeah.
yes, yes. So straight out of a printer, you'd be able to tell. But
Right.
there's probably been some post processing if it has been 3D printed.
Yeah.
Even if it's been injection molding, there might be a little bit of post processing done on it to get rid of the flashing and everything else,
Right.
because a lot of times you would be able to see that. So it's really hard to tell. What material is there, or anything else, but it really looks good. There's no doubt about it. The
Yeah.
finish on that
Well,
is
and
is
I'll
something
just make a
else.
note. while we're talking about materials, and you were very interested in this area, but if you look at
Mm.
the difference between the white part and the black part here, the black part I would guess is some sort of aluminum or something, because it looks like it's powder coated. You can see a little bit of rippling on the surface, where the
Mhm.
specular highlights are, that seem to indicate that that's more of a metallic thing that's been powder coated, and it's not absolutely perfectly smooth. Whereas the top part, and it just might be a trick of the light and the fact that it's white, but it looks
Yes.
more like plastic on the top part. So
Yes, yes, yes.
that
So
would be
the
my
lower
guess.
black part, you could see what is kind of that, I guess that glossy white area in there. That's
Yes.
indicating that there's like a little bit of notch or dimple in there, which at
Yeah.
first I was like, I'm trying to understand what that is because expecting it to be a very smooth surface. But when you
Right.
look at the video, you do notice in that lower section there, it's got these dimples on both sides.
Right. And you can see it over
You know,
here. You can see it
it's
right here
has something to
too.
do with the structure or whatever is
Yeah.
underneath that the reason for them to do that. So
Right.
yeah, it is there. And unfortunately, the waist area, it's because everything is so black and so dark, it's really, really hard to be able
Right.
to make out
Right.
too much of what's going on there. We'll try our best as we go along there. But again, if you look at the lower arm, if we kind of just zoom in on
Yeah.
that area
Yeah.
first as
Well,
we go
just
down
I
the
want
arm.
to touch on this
Mhm,
too, though, because
mhm.
my theory here is that you need some sort of an anchor point for these actuators to mount to grip onto, to move the upper
Mhm.
body, which is pretty large and massive overall because it's got the batteries and all the
Yes.
computers. So I would imagine that they've built something structurally into it that's essentially just
Yes.
a little handle for it to grab and to hold on to as it's turning
So
it.
yeah,
So yeah.
so underneath there's a structure where the actuator that's going to make the torso spin, or I guess
Right.
along the spine, because you got one that makes it go kind
Right.
of left and
Right.
right, and the one
Yeah.
that makes it allows it to rotate. That's the main actuator that is then
Right.
being bolted directly onto that. So that
Yeah.
is where the torso structure is going to be, and then of
Right.
course in there you've got that cavity that's going to be filled primarily with batteries. At this point, we think it's still 2170s because that's what it was in Gen 1, but the
Right.
cavity looks to be a little bit bigger. So who knows? Either they're putting more batteries in there or they could have changed the style of battery. But
Yeah.
having talked with Jordan Giesity today, and this is something I have to say is that, we're in this Rebellion Air group uh, set up
Awesome.
by Bradford Ferguson, where
Yeah.
we have access to a lot of very smart people. And that whenever we don't know something, we can lean on them. And I was asked a bunch of questions about, why wouldn't it be 4680s? Because it looks like in the T-shirt video, there's some 4680s that the other Optimus
A
bots are
lot.
playing with.
Yeah.
Why are they playing with it? And it could
Right.
be it's just an item for them to play with. It's not clear whether it's an Easter egg saying that it's going to be doing
Right.
it on the
Well, and then
automotive line.
there was
It's not.
the yellow Connect 4 thing
Right.
underneath.
They,
Yeah.
they
Yeah.
they already have automated that with
Right.
traditional robots that go very, very fast. They're not going to do it with Optimus. The question is, well, what about if they were building the battery packs for Optimus? That's a
Right.
possibility, but I still don't think it'd be 4680s because the energy density of 4680s only comes to the forefront at the pack level.
Right.
It
Right.
actually, the 2170s have better energy density than the 4680s. Optimus is really conscious when it comes to the amount of weight and the
Yeah.
amount of power you're going to have. So you're going to get the best energy density possible. And the 2170s right now kind of fit that bill because you don't need a structural battery pack. And Jordan kind of backs me up on all that. He doesn't really see a reason for that. The
Right.
2170s also have a better charging pattern than the 4680s right now. So it just
Right.
doesn't make sense. And do you want to take
And
that away from Cybertruck production? No,
yeah,
you don't.
let's not forget that also 2170s, there are a lot more of those. The Panasonic is really good at
Yes.
producing 2170s. So yeah. And
Yes,
other
yes,
companies.
and they're also increasing the energy density. I think
Yeah. Yeah.
they talked about maybe being able to get another 10% out of it,
Yeah.
and that would be great because that means the pack would go from 2.3 kilowatt hours to 2.5 kilowatt hours,
Right.
and that's nice, especially if you're losing mass and everything else that you get longer runtime. And
Right.
again, this is something I'm going to try to model out how you would get kind of the runtime with different charging patterns, stuff like that. If you're taking breaks during the day, what's that going to look like, and what would be the ideal battery chemistry? Is the normal sort of lithium ion with nickel the way you would want to go versus LFP, which
Right.
is a lot heavier, however, lasts a lot longer. So if you're going to be recharging this 3 times a day,
Yeah.
you're going to want to get a lot of life out of it. And
Yeah.
then
Yeah.
the other thing is that the LFPs, they can go from 0 to 100% without a problem.
exactly.
Whereas most other batteries, you're like, maybe it can run from 10 to 90%, which
Yeah,
means you're carrying around 20% that you don't need. And you can
right.
almost say, well, if I shave 20% off and then replace that with LFPs, is it even out?
Yeah,
So I don't know the answer yet because I haven't modeled it.
right,
Once we
right.
get the model, we can figure out what battery chemistry. But I'm assuming right now they're using the standard 2170s that are going and everything else.
Right.
Because I'm not sure that if they're making 2170 LFPs or anything like that, or if there's
Yeah.
any special chemistries or different
And
chemistries.
and also, Tesla does not have to, Elon always says don't optimize too early. So they may not have even decided at this point. They
Oh
they
yeah,
probably have to
yeah,
decide between 2170 and 4680 because that's
yes,
architecturally very different. But in terms of the battery chemistry, it may be agnostic to it. Maybe under certain, maybe a Tesla bot that operates in the cold, they'll put 2170s with nickel metal
right,
NMC,
right, right,
and then an
right.
LFP that goes in the factory that's in a nice environment will have LFP batteries. So who knows? So it could be
Yeah,
agnostic
yeah,
to it.
and that will be a while. I mean, that was one of the things that Brett Adcock really kind of pointed out is that within
Yeah,
the factory you have such a well structured environment.
right,
First,
right.
you don't have to worry about the environment. You don't have to worry about being too cold or too hot. You don't have to worry
Yeah,
about being too humid. You don't have to worry about rain or anything like that. So
right.
there's all sorts of things that can be done that
Um,
definitely improve things for you.
so let's just quickly touch on this. I distracted you from this, but you were talking about the pleating on this and how it's
Mhm.
very extensive. Show this. It's extended down the arm much further than you would have expected. Um,
Yes, yes. Because
so yeah,
there doesn't seem like there's any mechanism there. So when I was looking at the elbow before, at first I thought, well, wait a minute, does the drive mechanism at the elbow kind of go through there? And when I reviewed it, it's like, no, it's actually in the back of the elbow. So
hmm,
the part that kind of pokes out is in the back, and that's where the lever arm and everything comes down. And
right.
so you'd expect it, and there is some protection in the back, and we'll also notice in the back of the elbow, there is also probably some sort of black cover. We can't see it in this photograph,
Yeah,
unfortunately,
yeah,
um, but the pleated section there is much bigger and far more open, and I'm not sure why. And the only explanation might be perhaps some of the cabling is coming through there. So we'll
mhm,
notice. I mean, the one thing we didn't look at, and because we couldn't see it up on the shoulder, you don't see any of the cabling or the
right.
harnessing or anything. It's
Actually, there's
really
so
tight.
little
It's really
cabling
fit.
visible now. It's beautiful. Like they've
Oh
hit
yeah,
most.
yeah. You really have to go out of your way to kind of find it, and it's not
Right.
until we get down to the wrist that the cables start to kind of
Yeah,
expose
like right
themselves.
here's the
But
first real cable you can see is like right there
right,
at
right,
that
right.
area. So,
Now,
yeah,
now the thing we got to remember, what's going on that lower arm is you do have the wrist roll, which is going to be not
mhm,
quite plus or minus 180, but it's going to be substantial amount of movement, which means the
right,
cable that you're having through there is going to have to be able to deal with the fact that it's going back and forth quite a bit. So you're going to have some excess cable it's going to have to wrap and kind of unwrap, and that might be the reason is they just don't want it to be kind of constrained in there, and that they
right,
have kind of that open fabric area just to take the tension off the cable. It may be as
right.
simple an explanation as that. It could also be that you reduce a little bit of mass, but then again, those are plastic covers, so I don't think there's a whole lot of
Yeah,
mass there
yeah,
in the
no,
first place. Someone else has said it's also could be possibly just for to make sure you can get rid of any excess heat, because there are some servos kind of up there.
mm,
They're going to be
mm,
generating some
mm,
heat, so you might want to have a little bit, promote a little bit of airflow or something like that.
mm,
So there's many reasons, obviously, that for doing that. Those are just kind of my guesses. But then when you get
yeah,
to that lower arm, that's where I think the material goes from. It must be some sort of very strong, I would assume, metallic material along there, because
right.
there you've
So
got
that
some loading
this
going
area,
on there. You have the servos that have to be mounted,
right?
and could you come up with a plastic of some sort? I mean, you could clearly 3D print that because it's a rather intricate
Yeah,
shape, but you've got a couple of places that you have to pin the servos on there, and those are going to be places where you're going to have a lot of stress,
like
repetitive stress over time.
right there, for
Right
example,
now,
you can see it very well on that
yes.
wrist.
Now
Yeah,
you could drill a hole through there, and you could put a metallic sleeve in there, and that you then can pin in. But still, that sleeve is still rubbing up against a
yeah,
plastic piece.
yeah,
Even if the rubbing motion that you have inside of that of the two metal parts is metal on metal, that's fine. But you still
right,
have that in there. And depending upon the loading, maybe you can get away with it, maybe not. But my gut feeling is that you just can't use plastic there. So I suspect that is still some kind of metallic piece, and but it's been coated for the color match.
Right.
But then when you get
It
down
is.
to the wrist, you can see a
It
lot of
yeah.
exposed metal parts there that are clearly not coated at all.
Right. Yeah, that's the interesting part is because clearly starting right here with the piston of this actuator, that is in just
Hmm.
uncoated metallic. This part where the
Yes,
wrist is clearly just brushed metal. So it's like,
yes.
why did they bother with this? But maybe you're right. Maybe it's just an aesthetic thing. It's just it blends. It would look weird to have it go from white to suddenly like metallic, very large.
To silver, something like
Yeah.
that.
Yeah.
But again, to me, that sounds like an optimization. At this point, are you really
Mhm.
caring about the polish that this thing has? So
Right.
this is something I'm looking at. I say, man, this whole design, everything here is so polished.
It feels
It's like
very
it
done.
feels like they're ready for production
Yeah.
when you get that kind of polish on it versus something else. Or maybe they just decided, they really want to see what it's going to look like, and I'm reading too
Right.
much into that.
Right. Right. So while we're talking about this, so clearly we have still there's two linear actuators on the side that can allow the whoops, let's see if I can do this right. They'll allow the wrist to go up and down and also yaw back and forth. And then the
Yes,
wrist
exactly.
itself looks like it's got the rotational capability built in somewhere around here. And then of course we've got the fingers, which these fingers, as opposed to figure one that has three joints in the fingers, this clearly has two. It's got the
Two,
finger
yes,
pads
yes, you can see
and
it.
then these
And
other
and
ones.
if you go to the well, I guess to the left side, what would be the right hand, you can kind of see
Yeah.
the knuckles a little bit better.
Right.
So that one, when you go up there, yeah, you can see that the fingers only have two knuckles.
Right.
You can see that the knuckles were the fingers that get attached to like the palm. You can see
Yeah.
they are offset. So they're maintaining that offset to get kind of a simulated arc of the fingers, because the fingers are all the same length.
Yeah.
They're not making them different lengths because different parts, different SKUs, and everything else. So the best thing
Right.
is keep your part count down, make them all the same. But they mounted them a little bit different to get that. The thumb, a lot of people were wondering about the motion of the thumb, where there was a joint there. Yes, there is a joint there, and the thumb is
Right.
able to move in two directions. So
Yes.
it's got kind of
I
this
think you can
movement
see that
here
better over
and a
here.
movement up and down. Right.
Yeah.
Right.
You
So
can see that
it's
there's like
designed to have 2 degrees there
yeah.
at that, whereas
Yeah.
the fingers just have a single degree of freedom to be able to kind of clasp and open up. But the
Right.
thumb needs to be able to make that movement. Otherwise, they would not have been able to pick up that egg. So
Yes,
you definitely need
exactly.
that. And maybe even the same thing with a t-shirt. I mean, that's the kind of dexterity you get from the thumb. And really,
Right.
that's what separates us from all of the other animals is the
Right.
fact that we have an opposing thumb.
Right. Yeah.
That's
That's
what
the
made
thing.
the difference.
And I also, just as a small note, that, just from my animation background again, they've got the resting position with the finger slightly closed, which is much more natural. Like if it was looking like this, it would look like a robot. And so just the fact
Hmm.
that it kind of has relaxed hands where they're, not perfectly straight up like this makes it look more natural as it's resting. So it's
Yes,
again,
yes.
it's pretty deep into the design process when they're considering these kinds of things. And of course, don't forget that we also have pressure sensors in here, which we discussed in yesterday's
Right,
video
and
as
if you go to
well.
the other hand, you can see those
Yeah.
pressure sensors a little bit
Yeah.
better. So we know they're on the tips. We just don't know. We do
Right.
see some black areas on the middle of the fingers, and we
Right.
just don't know if those are non-slip grip or
Yeah.
if they are also their own set of pressure sensors. Now
Right.
the fact that they have sensors there and that you would need to have wiring to go along with them,
Right.
going through the fingers and then out through the wrist. And then when we're looking at the wrist, we'll see that the wiring going through there is very, very thin. So, you know, whereas before it seemed like it was very bulky, the kind of wiring that was going in the hand. So they've
Yeah.
done a very good job. It's
Yeah.
still a little bit exposed, but it's not that bad. It's
Right.
almost like it's not there.
Yeah, this is where we can primarily see wiring in the body, like this, like coming
Hmm.
out of the wrist, because it would be essentially going through the human wrist is a complete disaster. It's just a whole bunch of little tiny bones and all this stuff going through. So in terms of design, it's better to route the cabling outside of it, although it's not the most
You've got no
aesthetic.
choice. Even the human body, we had to do that.
Yeah,
So we are jointed, and things have to kind of go through there. And you've got a really weird joint at the wrist, and of course, you've got your artery to expose there. So normally,
mhm,
arteries in the
mhm,
human body
mhm,
are
mhm.
deep internal, so you don't accident if
Right,
you get a cut, you don't bleed to death, right? But
right.
there's only a few places that the artery coming up at the surface, and one of them is around the wrist because that's the only
Yeah,
way nature's been able to figure out that's how you get the artery out to the hands because
right.
you just can't route it through the center. And
Yeah.
that's the same kind of problem here, this conundrum of like, what do you do with the wiring? That's the
Right.
best place to do it, because you won't kink it so much. It won't get in the way. It's not right where the joint is. So
Yeah.
in all robotic systems, figuring out how to route the wiring is a challenge. End of
Yeah.
arm tooling, a lot of it is just exposed. Um, Paint robots have come up with a very special kind of what they call a hollow wrist that actually allows them to run
Mhm.
the paint services and everything out to the gun internally, which is rather a remarkable design. But still, that
Right.
wrist design has to be kind of offset as opposed to
Right.
having everything rotating around one place, because they don't want to take the hoses that are going through there and kink them in any way. So you
Yeah.
still have to make sure that your radius of curvature is not too big. So it's always a challenge, and that's not bad, what
Yeah.
they're able to come up with. Now that we're in that area, we can take kind of a look at the pelvic area, because we'll
Yeah,
see
yeah, yeah. Let me
there's a
ask you
lot
one
going on
question
there.
before we
Mhm.
turn to the pelvic area. Why there's cloth covering most of the other areas of the body that are exposed? Why not cover this with some sort would it just look ugly as hell just to have this
I
big
know, I
block?
know. I mean, everything else is covered except the naughty
Yeah.
bits.
Yeah. So I don't know. I don't know why they didn't cover it. So it's interesting that they have not done that. But this,
Yeah.
yeah, this is very even though it's black, it's really cool how much we can see here,
Well, we have to
including
thank Ed for that, because he was able
yes,
to highlight
yes,
it a little bit
yes.
better so we can see that contrast. Before, I had no idea. It was
No,
like looking
exactly.
into the inky blackness and seeing absolutely nothing. But I
Including
mean, the one thing we could
these
see
little
is
guys. These look like standard Allen wrench, bolts.
yes,
It looks like
yes.
it's nothing special right there. So yeah,
Exactly. And it shouldn't be anything special. It should be something
yeah,
that's very easy to put together. So we can see how
right,
they're bolted together. It's
right,
basically the three same motors just being configured for, two of them for the legs, and two of them are for
right.
the torso. Um,
Yeah, let me actually
the
back off one little bit here because I think
mhm.
so. The torso, this is the one that's going to yaw it. I guess yaw. I don't know.
Yeah, there's going to be like there's
Yeah,
going to be a
so
roll
that'll
on the
go,
top, and there's going to be the bend back and forth,
and
whatever
then
you
this
want to
one's
call
to
that.
bend back and forth back here. So we've got
Yes.
two different.
Now the thing to point out is the torso in the Tesla bot is not able to lean forward through
Yes,
the torso. Okay,
yes,
there's only 2 degrees of freedom there. So
right,
the main movement is it can roll directly vertically along the spine, and it
right,
can kind of go back and forth, so, a little bit left and right. It
right,
cannot lean forward. The leaning
right.
forward is actually done through the hips.
Yes,
So it's through an axis that's much lower. It's below the pelvis and actually where the hip joint is, and what
right.
would usually make your leg do what I think is called flexion. If you're kicking your leg, it
Yes,
comes there because it's a redundancy. You don't really need it. And for most people, when you ask them to lean forward, they're almost doing it through their hips anyways.
right.
You
Well,
can do it through your tummy if you're flexible, but for
right.
a lot of people, it's a lot easier to actually do it there. But with the humans, are that hip joint is actually higher up on the pelvis,
Yes,
whereas
yes,
in the Tesla bot, it seems to be a little bit lower. So it's a slightly unnatural thing. Now, the figure bot, they came up with a really interesting design for the torso where they have 3 degrees of freedom there. So they are actually able to lean forward through the torso, and then should also be able to do that. So they have a little bit more redundancy, which means it might be easier for them to get in and out of a vehicle if they ever needed to. Um,
right, right.
it's just a slight difference there. But the main
Yeah,
reason that the Tesla bot doesn't do that is that they reduce the actuator. It's one less actuator.
right,
The other thing is that you have kind of that same pattern of these two motors bolted together,
right.
and they want to do it in 3 places. So in other words, what they were doing is they were reusing that pattern rather than having to come up with yet another unique pattern somewhere. So that's like the thing is kind of clever and nice about the design and the decision. It's
Right.
like, we don't really need to lean forward because we can accomplish it another way. You lose maybe a little bit of flexibility, like I say, for being able to access things if you wanted to be able to literally sit in the Cybertruck.
Yeah.
Um, but the big change that we can see here from the Gen 1 is that the Gen 1 pelvic girdle, there was a plate in the front and in the
Yeah.
back.
Yeah. And now we only
And
have
then
the
and they were
back.
connected together. There's only the plate in the back. And that there probably is like a kilogram of material.
Yeah.
That
Absolutely.
I think there's like a big weight saving right there, as
Right.
well as those servos look a lot more compact than they were to begin
Yeah.
with. Way
And
more
also
compact.
look at the pretty dressing of the cabling here. We've got these cables in sort of
Exactly.
chaseways
You
that
almost don't
come
notice them.
around.
Yeah.
yeah, I mean, it looks like part of the design, but that's clearly the plug that plugs the,
There,
the cable
and you could
into
see
the
the plug where it goes in there. It's a beautiful cable
yeah,
design. Very,
yeah,
and you're kind of trying to figure. Whereas before there were a lot of wires around there. There was also some other
right.
control boxes that were kind of sitting down that had blinking LEDs and everything. It looks like all that stuff they integrated together. Now again, this is something that James Dalma pointed out. I was asking him about some of the weight savings, and he felt that when you start to redesign a lot of the electronics, because the original stuff they were probably just slapping whatever electronic
Yeah.
boards they could get together.
It's like,
But
"Yeah,
once they
this'll
start
work."
to redesign that, the boards and everything, and the controls and the harnessing, he says, oh, they could probably lose a lot of weight right there
Right.
very easily by tightening that up. So
Yeah.
part of that, the battery management system, everything else is going to be in there when it starts to
Yeah.
get designed properly, as well as the actuators. He was pretty sure they can lose a
And
lot in the
this
actuators.
starts to make it, like, a little more idiot proof too, because there's not cables.
Hmm.
It's the kind of thing where if it's walking past you in a factory thing and you reach out your hand and you snag a cable and then the cable gets pulled. Like, here, they're all very, very tightly,
Yes, yes, yes.
nobody's going to catch their fingers on that and accidentally grab that and
Right,
pull it out.
right.
It's
Now,
very thick and
and I'm kind of looking in there. I mean, there's still potentially some pinch points. I'm almost thinking
mhm,
whether they
mhm.
eventually will have
A
something to
covering.
kind of
Yeah.
cover that whole thing up.
Yeah.
And maybe they just haven't worked on it, or maybe they just decided they don't want to put it on there for now and see what the reaction is.
Yeah.
Um,
Well,
but as
or
far
the
as for
use
accessibility
cases.
and working and things, yeah.
Right. The use cases might be that they're just like, we don't need to do that for right now because it's not
For
going
now,
to be
yeah.
in a situation. I would assume that if this was going into the home, it would need most of this stuff covered
Hmm. Hmm.
because
Yes,
that
yeah,
is a yeah.
yeah, yeah,
Um,
yep.
so this is very curious to me. Like this whole area here, it looks like kind of like a bunch of little rollers or something. That was the part that
Well,
blew my mind. I was like, what is that when I looked at
oh,
it?
well, if you go back to the design, it's the kind of the 4-bar linkage that they use for both the knee and the hip, because
Okay.
they
Okay.
have the actuators for those are linear actuators.
Okay.
And so if you're using a linear actuator, I mean,
Oh,
it's
so it's
in some ways
connected.
a linear actuator is funny because remember, in the end, we're trying to create rotational motion about a joint.
Right. Right.
And one way to do rotational motion about a joint is to actually turn the joint into an actuator itself,
Right.
which you see in many places in the Tesla bot.
Yeah.
The other is that you displace the actuator somewhere else, and then you use some sort of linkage mechanism to do it.
Right.
So you basically have a rotary motion that causes a linear motion that causes a rotary motion,
Right,
and
which is
they're
up
doing it
here. We
with
can see
linear
that right
actuators
here.
instead. And a
Yeah,
linear actuator, of course, you've got a rotating a rotary motion inside the actuator,
right,
which causes through kind of a ball screw drive mechanism to
right,
create this linear movement.
right.
And then now you're trying to figure out how do we take this linear movement and then turn it into a rotational movement somewhere else. So
Right.
you're adding a certain amount of complexity when you do that. And when I had spoke with Brett Adcock with Herbert, kind of talking about that,
Mhm.
the feeling was they don't have that many linear actuators just for
Right,
that reason that as soon as you put it in there, it means you don't have a single joint. You now have like two others, which are kind of idling that are moving around. It adds a little bit of complexity, but there are advantages to it. So especially in
yeah.
the wrist, and when
Yeah,
we
which
look
is the
down
part I've
at
got
the
outlined here,
ankle,
yeah.
it
Yeah, yeah.
really, really makes sense to do that because they're getting that 2-for-1 kind of thing, and depending upon
Right,
the range of
right,
motion. And the other decision was that they're able to kind of fit the actuator. I mean, even on the elbow, I mean, the elbow, you could make a rotary actuator there, but Tesla decided, well, wait a minute, the human arm, you've got this space kind of up here where the bicep
right,
is, the sort of
right,
empty space. Maybe we can pack a big actuator in there that gives us
right.
way more torque. And then through using the linear drive, we just go ahead and use that to get us what we want. So
Yeah,
those are sort of the design decisions. You could say, well, wait a minute, I've got volume somewhere. And that's what's going on in the leg is that you
I
could, and we've seen, I think, with a couple of other Chinese robots that were designed to try to get the torque that they need around the hip. They've got a pretty big actuator there that seems
right.
like it takes up way more space than you'd want to have. And then they've got a lot of empty space because some of those bots, when you look at them, they look like stick figures walking around
Yeah,
because
yeah,
the actuator is somewhere else and all you need is that bony structure. And what,
right.
what, what Tesla has done here says, well, wait a minute, rather than just having bones there, let's go ahead and fill that leg out a little bit and
Yep,
put our actuators and shove them in there because that's space that's okay to kind of take up.
right.
You want that. So that would
And
be part of the design decision on why you want to go from rotary to linear, but it does
yeah,
add a kind of complex mechanism. And if you go to the AEI Day 2 presentation, you will be able to see the knee design and the hip design and everything else in there that
Right.
will explain what's going on there and why and we can't see it because most of it's covered up.
Yeah. But I was going to say the other thing about this is that you get more torque out of linear actuators
Hmm.
because of the fact that the ball screw joint is effectively moving at a small amount per turn of, like, if you think
Yes.
about it, if you take an elbow and you just have a rotational actuator, this is 90 degrees. That's like you're rotating at 90 degrees, you get 90 degrees. If you want to do 90 degrees on a linear actuator, it could spin many, many times. And so you
Many
saw that
times.
thing be able
Yes.
to pick up a grand piano,
Yes,
the
that's the
linear
main
actuator.
reason is
Yeah,
you get incredible torque because it's effectively a built-in transmission system.
exactly.
So
Exactly.
otherwise, if you do a direct drive, then you're going to have a lot of torque to be able to do it, and
Right.
also you lose a little bit of finesse
Yeah.
because you're moving just a
True.
little bit
True.
on that actuator, so you don't quite get the precision unless you build a gearbox into that whole thing, which you
Right.
potentially can also do. But that then you're kind of like, well, we've sort of lost the whole advantage of having a direct drive there. So you're right.
Exactly.
With that ball screw, you get the mechanical advantage of being able to do it and very
Right.
precise control and
Yeah.
incredible amount of stiffness if you need that. And and it still can move pretty fast if they need to. So we were able
Right.
to see that, yeah, you can lift a grand piano. That's pretty strong.
Yeah. And you're right. The disadvantage, of course, is maybe that's going to limit the speed of Optimus walking because there is only so fast that these can go, you know, they may have to
Yeah.
go a little bit faster than that. So it may actually limit the speed, or they may have to develop a faster linear actuator that
Yeah,
can,
I think they can probably go fast enough what they need.
yeah.
And now the other thing is when you do a linear drive versus like if you go to the elbow and
Yeah.
you decide you want to put a rotary axis there, the thing
Right.
about a rotary axis is it can move pretty far around. So you could make your
Yeah.
elbow almost go plus or minus 180 degrees.
Yeah.
You
Yeah.
know, not quite, maybe plus minus 120 because you have some mechanical constraints there. But
Right.
as soon as you decide to actuate it with a linear drive, it it limits your range of motion, but
Yes.
that's okay because the human body has a limited range of motion anyways, because we
Right.
effectively are almost the same kind of mechanism. We don't
Yeah.
have a rotary axis. It looks like we have a hinge joint at the elbow. We don't.
Right.
And,
Right.
and we get this muscle that pulls on a tendon that almost works the same way. So we've got only about 120 degrees of motion. So you don't want more. You don't want your humanoid bot to be able to have greater range of motion than the human.
Right.
Yeah,
Right.
maybe a little bit. It'd be nice to have that, but you don't want to have a double uh, jointed elbow or anything like that.
It's like
So that
flopping
means
over
you
back.
could decide, oh, it's acceptable to do that. Same with the knee. You know,
Yeah.
the knee, I don't need to have a rotary actuator there. I will do it with a linear one because
Right.
I only want the knee to go straight out and flex back at most 120 degrees.
And speaking of which, now we can see like kind of like knee pad, kneecaps now that
Hmm.
they have. So that is over that.
Just,
They're
it's
in
basically protecting what's going on there.
right.
And you can't quite see it, but it does open up when it moves.
Yeah. And this also is a little bit less human friendly, of course, again, than the elbows, because we can see inside and you could imagine pinching your fingers. But again, this is a situation probably fine for an industrial robot, would not be fine for a domestic robot, but we're not talking about domestic robots yet. So, so it can get
You'll
away.
put something around it, like, you know,
Yeah.
when you sprain your knee, you
Yeah.
get one of those
An ace
bandages that you kind
bandage.
of stretch over it. I mean, they can have socks and other stuff like that that would
Right.
be able to go
Right.
up there and kind of
Yeah,
cover it and protect
exactly.
it, as
Yeah.
well as that, they might put some sort of material behind those knee pads also to give additional protection.
Yeah. Yeah. Do you have an explanation for what this black part is? Is it just aesthetic, or is that like, what is that thing?
Yeah, I mean, that's kind of weird that, um, again, it looks like it's some sort of potential cover going on down there, and
Yeah.
it's only on the inside.
Right.
Again, it could be that they just want to be able to get airflow or something like that in there, or because the cabling might be coming through there.
Yeah, there's definitely cabling coming
It's
up
really hard to tell.
through. You can see the cabling coming up through here, right? Like that,
Hmm. Hmm.
more or less. So maybe it's flexible that as the knee bends and cabling kind of comes in, it's able to flex a little and move out of the way so the
Yes,
cable's not
yes, the
getting
length of the
trapped.
cable is going to change a little bit,
Yeah.
but there's no rotation along those axes, so
Right.
it's really
Right.
just the bend that's going on there with the knee.
Yeah. And
Yeah,
really
that's
very,
kind
very attractive what they've done right here too, is they've created a little channel for the cable to go through. Um,
Yes,
makes it
yes,
very,
yes, and it
yeah,
goes, yeah, it goes through there, and you see it kind of also separates out a little bit when it gets down to the
yeah,
foot. So
yeah.
if we bring it up there now, there's
Here.
like the ankle joint. if you kind of zoom in on one of the feet,
So, well,
especially the
let's
one
okay,
on the,
just so we make sure
yep,
we touch on this for anybody who doesn't know. So this is very much the same as the wrist. We've got two of these linear actuators that can work in parallel or they can work
yes.
opposite each other to allow some
And this
degree of
this is the this is the beauty that, again, I've pointed out many times, but I want to point
yeah.
out again, is that when it comes to the hand, you've got these three motions. You've got the
Mhm.
roll, which they have a dedicated motor for doing that. That can almost
Right,
give you 360 degrees of
right.
rotation. Then you've got this pitching motion of your hand
This
flopping
guy right
back and
here.
forth. And that's not
Mhm.
quite 180 degrees, but it's a very important motion. And then you get your yawing here, which is like it's almost not there, but you have a little bit of movement to the
Right,
left and to the right. And
right,
you can decide that you have to go ahead and put a motor on there, but it's like a lot of overkill. And usually that's the last joint of movement. And so you
right,
have this servo that you have to put there to do that, that now has to be carried by the one that's doing this, that
right,
has to be carried by the one that's doing this. So that means you kind of lose the advantage of that for this little bit of range of motion. Well, by
right.
going with a parallel mechanism, you
Yeah,
can come up with a parallel mechanism and then they both move in the same time. Your
right.
hand flops up and down.
Yeah,
But if they go differentially, you can kind of get that. But mechanically, you can't do it by a whole lot. You might be able to do plus or minus 30 degrees, maybe plus or minus 45. But if you actually look at that
right.
mechanism, it has a lot of movement. It will allow movement this way, but you can't do too much off this way. And that's okay because that's exactly how the human hand works.
Yeah,
So what that
exactly.
means is that those two motors do not have to carry one another. They're
Right,
separate.
right. Yeah.
All they have to do is carry the hand, which is great. The other thing, if you add those two motors up, they have a lot of torque,
Yes.
especially when you go down to the ankle. So the ankle mechanism is the
Right,
same thing. For the most part, our feet like to go back and forth like this. They don't like to turn back and forth. I mean, if you do a lot to the left or right on that, that's how you sprain your ankle, right? You know,
yeah.
if you step on something that's,
Yeah,
yes. So we have a little bit of movement there. And the Tesla bot has a little bit of movement there that's also allowed by it. But the main movement is that they could do the toe off kind of action there. But
right.
the calf muscles, the two of those motors added together have almost the same torque as the actuators that are in the hip joints
Right, right,
that are moving the knee and are moving the hip,
right.
just a little bit underneath that. So that means there is a lot of power there when you decide you just want to direct it on the toes
Yeah,
and then a little bit to the offside. So that's the other advantage is that you can decide that, yeah, I want all that torque for this one particular action. You'll be
right,
able to get that in there.
right.
Now this, okay, is when I was looking at down by the foot on what is the Tesla bot's right foot to our
Yeah.
left. If you zoom
Yeah.
in there, you can sort of see the very end of that shin bone when it comes down there, and you can see the joint that's there, and you can see how it's silvery. You'll see how
Yes.
the white kind of ends a little bit. And for me, that was the clincher that it's coated metallic,
Oh, so there's no
probably
code. You
coated aluminum.
yeah, you can see that
I
right
just
here
don't.
too. Yeah,
Yeah,
yeah.
I don't think it's like, oh, they tried to figure out how to bolt that plastic. If it was, let's say, a plastic cast piece
Right,
or printed onto there. No, that's one solid thing.
right.
So it looks like they are um, coating it somehow, and then you can see the exposed metal that's there. Now, it was a lot of people ask, could they be using magnesium? They could be. I mean, because they lost a lot. That magnesium would be one way to go. My feeling is that at this point,
Right.
probably not. I don't know whether Tesla, let's say, has the expertise to do magnesium. It may be that there is no expertise required to do normal machining of or
Right.
casting of magnesium. I'm not sure, but I'm
Right.
assuming maybe it requires a little bit. Jordan, who has also been doing a deep dive into magnesium recently, as we know, he feels
Right.
that it also would be too early because you've got to get the magnesium supply chains and all these things up and running. That it's not cost effective right now. You would be
Right.
able to get a little bit of weight savings, but again, he thinks it's too early. It's an optimization step. So
But
I'm pretty
also,
confident it's a type of aluminum that's
yeah,
just coated.
raw magnesium even silver? I thought it had kind of a coloration to it. So again, the
It
fact that
could.
this is like raw and looks very silver, I could
Yeah,
be wrong.
and then of course there's alloys, and
Yeah.
it's not going to be pure magnesium. We know it's going to be some kind of alloy because the biggest thing everyone says about magnesium is like, oh man, it just burns. It's just
Yeah.
the stuff you put in fireworks.
Exactly.
But so what you do to be able to actually work with magnesium is you just alloy it a little bit, and you don't have to worry about the
Right.
flammability or anything like that.
And I'll add one other thing to the metallicness, especially in the legs. I mean, these two guys produce, like you said, just a little less torque than the hip joints, and it's supporting the entire
But
body.
enough to lift a grand piano.
Yeah,
Okay, so that's a
but
lot
what
of
I'm saying
torque
is,
going through there.
yeah, so that, and in order for that thing to hold that much torque, it needs to be. There's no way that's plastic. It would shatter that
No way
sucker.
that's plastic. Yeah, yeah, exactly. So that's why I don't think it's there. Now we
Yeah,
can't see too much detail in the feet, but we know from the video that the toe box has some flexibility. If you're looking
yeah,
kind of really closely, you might be able to see where the flex point is
right. Yeah,
towards
it's
the
a
front of
little
the toe
bit like
box.
here. You can kind of see where it might be a little worn or something like that,
Hmm.
like kind of across this area.
Yes,
But yeah, and across this one you can see, and it just looks like it's like a shoe. If like you wear a shoe for a while, you see what
and
you're.
it's a degree of freedom in there, but it is not an actuated degree of freedom.
No, no, no. So
So
probably
what
what
that
just
means,
a torsion bar that's pulling it back to straight, and so it just
yes,
presses it.
some kind of spring mechanism in there
Yeah,
that's making sure it kind of flattens out. So it
right,
goes up on the toe and it will bend a little bit and then will kind of give that energy back.
right.
So articulated but not actuated.
Yeah, yeah. Yep. So there we go. We've gone head to toe on this guy. Let's zoom back out again. He's very attractive. I mean, I think what we're both noticing from looking at this amount of detail is that this seems like Tesla seems like they're starting to optimize the design here. It's no longer just get stuff off the
Yeah.
shelf and like slap it together. It's like, no, what is this thing going to look like when we make a million of them? So
It doesn't look rough, and again, the
yeah,
Tesla logo is on there, which is already like, well, it's like
yeah,
it seems like you're getting close to a finished product when you decide you want to put the branding on it. But even forgetting the Tesla logo, just looking at how polished the whole thing is,
hmm,
how well everything fits together, the aesthetics of it
right,
seems like they must be getting close to thinking that we really want to start building a lot of these things. But again, they're
yeah,
not building them to sell, as far as I know. They're building them just for internal use
exactly. But
at
still,
first.
exactly.
Yeah.
But also, I mean, just look at I'd noticed this particular spot, this joint. Clearly there's two halves of like a clamshell they're putting together, but that is a that's a perfectly straight line with no panel gaps, and around this
Hmm.
direction too, as these two as the roll joint fits with the other joints. Any place you look, it's very, very refined.
The
It's
quality
yeah,
is really good. It's really refined. And again, it seems like, well, wait a minute, you're almost getting down to step 5 in the algorithm.
exactly, exactly. So very, very interesting because that who knows how many iterations they went through. The other interesting thing was when we watched the folding of the clothes that we saw most of the other Optimi that were in that lab were generation 1. They were still the
Gen
silver.
1, yeah. Where's the Gen 2s? I was
Yeah,
expecting to see a plethora of Gen 2s back
right,
there, but yeah, they were all pretty much Gen 1s. And as far as we know, there's only 2 Gen 2s because we've only ever seen 2 of them together.
right,
But looking at this, it's like, wow, is that just like a one-off where they really just went in and artistically get everything perfect?
right,
Or are they kind of set up to be able to start producing these parts of these components to create a pretty large set of them? And again, we've been talking to a lot of different people and the experts to get an
right.
idea of what they think is the number you would need for it. The early training sets, it felt like there was a certain amount were able to do just with simulation,
Yes.
but you can
Yeah.
only go so far. And James has sort of said this again. Brett is that the physics in your simulation is only so good.
Right.
Real world
Exactly.
physics is messier, and in order to sort of tune everything, you've got to start getting it, and you've got to start collecting that data in the real world.
Right.
So you can do so much tele operated, you can do so much with simulation, but at some point you've got to get the bots out there, and they've got to be interacting to see a lot more.
Right.
And that's why the expectation is that you would need a reasonable number of bots, and
Yep.
whether that reasonable number of bots is dozens, hundreds, or thousands, that's sort of a point of contention right now.
Right. Right. And we don't know exactly. Did Sawyer say exactly where this photo was leaked? But
I don't know if it was leaked, but yeah, I think he said something about, they released this, and
yeah.
he
Well,
seems
okay.
to know where to go on their websites
Yeah.
and find it.
Exactly.
Maybe it was actually on the Tesla bot
Right.
X account, and we just didn't bother to go over there
Yeah.
and take a look.
Well, the reason
So
why I'm throwing this out is because, of course, we got big announcement from Figure recently, a lot of press going their way. So it feels like Tesla is kind of, I think what you were saying previously was they were waiting until major events to announce big giant updates, and now they're being a lot
mhm.
more aggressive about micro releases. It's like, hey, it's folding a shirt. Hey, here's a high resolution picture. It's like let's keep this in the public eye and don't let people forget about it.
Right, right. And by the way, we have earnings calls tomorrow for Tesla,
That's
which
right.
means this video is going to be going out in the morning before that
Yeah.
happens to keep
Yeah.
everyone sort of entertained until then, because then for the
Consider this
next couple of
whetting
days, it's
everyone's
all everyone's going to be
appetite.
talking about.
Yeah,
Yes, no
exactly.
one's going to care about this after this unless there's some intriguing question about Optimus
There you go.
that comes up, and then once again, my vacation. It's
So there we go. It'll all happen. Well, maybe what'll happen is Elon will say, like, I watched Scott and John's video yesterday and they were dead on except for these 2 points, which I'll explain. And then we'll be like,
yeah, yeah, right,
oh,
right, yeah.
so there you go. You never know. It could happen in our dreams at least. So cool. Well, thank you so much, Scott. And it's very, very late at night there. And you just had an evening at the opera. So thank you for taking time off from, just enjoying your life there and everything.
I
So
think the term is night at the opera, right?
right. So, all right. Well, thank you so much. And everybody, I don't know, follow Scott. Make sure it says Going Ballistic 5. You don't even have to look in the description. It's right there. You've been staring at it the whole time. So follow Scott on Twitter or /X and subscribe, do all that good stuff. And we'll see you in the next video. Bye-bye.
Yep. Thanks, John. Bye, everyone.